Well, good morning, everyone. Welcome to SMP's Wi-Fi 6 Powering New Experience webinar. Just a couple logistical things before I hand it over to our presenter, Moorhead. During the presentation, if you have questions, please feel free to put them in the Q&A section of the WebEx. If there's time at the end of the webinar, we will open up the lines to live question and answer session. And if there isn't time and you still have questions, please feel free to reach out to your account manager or email SMP at solutions@smp-corp.com, and we will be happy to get back to you promptly. Another final logistical thing, we are recording this session so that if you want to share this with other folks, reach out to us as well and we can share that with you. And with that, I am going to hand it over to John Moorhead, who will take you through Wi-Fi 6. Thank you. John, you might be on mute still.
There we go. Can you hear me now?
Yep, sounds good. Thanks.
Yeah, sorry about that. So thanks, Jennifer, and thank you, everyone, for joining SMP's webinar today, Wi-Fi 6, Powering New Mobile Experiences. Again, my name is John Moorhead. I'm a Senior Solutions Architect here at SMP, and I've been working for SMP for almost 6 years, and it's going on 30 years now of experience in the IT industry. And I have a pretty extensive history with wireless technologies since the mid-90s. I'll talk a little bit more about my past and throughout the presentation here. So let's briefly review of the agenda, and then we'll jump right in. First, we're going to start off with a quick overview. We'll talk about some of the market drivers and the reasons why you want to consider adopting Wi-Fi 6. And some of the use cases around that. We're going to go into some of the technical features and what the benefits of those technical features offer. And we're going to talk about some of the certified products out there, and some other Wi-Fi 6 products, specifically, around Cisco and Meraki. But obviously, the first two, the overview and the features and benefits, are going to be for any products out there that are 802.11ax or Wi-Fi 6 certified. So we're going to also have, for those that may not have worked with SMP, we'll have a brief overview for about 5 minutes or less at the end. And we'll do a quick summary and wrap it up if we have time. For questions, Q&A at the end, we'll definitely open up the lines. But please, if you do have questions, please put them in the Q&A. So in case if we don't have time at the end, we can get back to you directly on those questions that you may have. Let's jump right in on. I don't know what's going on here. Sorry about that. So let's jump in on the overview. Wireless is really evolving, and it's driven by more and more devices, more connections, more bandwidth-hungry applications. Future networks are going to need more wireless capacity and reliability. So that's really where the sixth generation of wireless is, really comes in. To meet these demands of growth and, security threats and things like that. So just going a little bit deeper here, this emerging standard, the IEEE 802.11ax standard, is really the latest step in a journey of, what we've seen across the multiple generations of nonstop innovation in wireless. And really 802.11ax really builds on that, on the strength that 802.11ac is providing, but it adds a lot of flexibility and scalability that really lets new and existing networks power some of the next generation applications. Some of those are going to be augmented and virtual reality, 4K, 8K streaming, and really a ton of IoT devices that are really coming, onto the market. And majority of those IoT devices, probably in upwards of close to 80%, are going to be all wireless. So, historically, each generation of cellular, 2G, 3G, 4G has really offloaded more and more traffic on the Wi-Fi, and that's going to continue happening. Really due to the superior speeds and economics, that Wi-Fi provides. Really, Wi-Fi 6 is complementary to cellular 5G, and they're really closely intertwined. They're built on the same technology foundation, and really as a result, they both bring significant performance improvements. As evidence of the close linkage between 5G and Wi-Fi 6, Cisco has a technology called open roaming. It's going to allow consumers to roam seamlessly between 802.11ax and 5G networks without having to deal with service interruptions. So there's a lot of synergy there between the technologies. Now, while 5G will pretty much reign and be supreme, the technology to go to for outdoor scenarios, Wi-Fi 6 will take precedence inside buildings and with devices that don't move around too often. Also important to note the fact that Wi-Fi 6 adoption is definitely going to outpace the adoption of 5G pretty much by a wide margin for years, and that's according to ABI research. So a little bit more about my personal experience with wireless technologies. Really predates this chart. I worked for a company back in the mid-90s called Telzon. Telzon was manufacturer of portable, the term that they used was portable teletransaction computers. Most people typically refer to them as mobile handheld components, computers with barcode scanners today. And back in 1992, actually the company Telzon, they acquired another company from Canada called Telesystems, SLW. And the reason I'm bringing that up is, Telesystems they started in 1986. They developed spread spectrum radio and other radio network products for local area networks and portable computer marketplaces. And this company, Telesystems, Telzon, spun them off in 1994. They bought them in 92. They spun them off in 94. And the name of that spin-off company that they spun Telesystems off was Aeronet Wireless Communications. And anybody that's worked with Cisco and wireless with Cisco in the past knows that, Cisco basically purchased Aeronet in 1999. So that was their foray into the wireless market. And really to this day, they still use that Aeronet, the Aeronet name, in their product portfolio. Now, one thing, however, the latest, 9000 series APs are now using the name Catalyst really in lieu of Aeronet. So, you're probably going to see over the next couple of years, the Aeronet name may be phased out, from that Cisco portfolio. Now, if we look at this chart back in 1999, that was the year 802.11b was ratified, but there was actually a IEEE, 2.4 gigahertz ratification prior to that. That was actually 802.11. The name was 802.11-1997 for the year that was ratified, and that was actually for data rates it only ran at 1 or 2 megabits per second. So we fast forward to Wi-Fi 6. The Wi-Fi Alliance really recently adopted that new generation naming conventions for Wi-Fi technologies. Really the goal was to make it a little bit easier and understand for the average consumer, as opposed to what I call the alphabet soup used by the IEEE. The 802.11ax technology, which is really, a major shift from previous versions of 802.11, that's why it's been given that next generation name of Wi-Fi 6. So it's a big shift, and we're going to cover some of that, the differences between 11ac and 11ax. If I use the term 802.11ax and Wi-Fi 6, they really mean the exact same thing. But, the term Wi-Fi 6, may become more prevalent with the general population. Technical people, IT individuals may still prefer, the IEEE naming convention, but they're interchangeable. Of course, Wi-Fi 6 devices are going to be mandated to support 802.11a, B, G, N. This really ensures that, you're investing in Wi-Fi 6, all clients and access points are going to be backward compatible with legacy APs and legacy clients. So Wi-Fi 6 is really enabling LAN-like multi-gigabit performance, and it really does this by, it offers 4 times throughput increase over 802.11ac. by doubling the number of RF chains. And it also provides 2.5 times more throughput to a single client, allowing up to 1.2 gigabits per second via a single spatial stream client. So some of the other reasons really that organizations are considering Wi-Fi 6 are there's an improved security with WPA3, there's lower latency, increased power efficiency, there's improved 2.4 gigahertz coverage that's going to allow for greater IoT scaling improvements, and better quality of experience by improvements on how interference is mitigated, especially with co-channel interference. We're going to cover a lot of these things in a little bit more detail going forward. So again, Wi-Fi 6 is really going to enable new and improved existing mobile experiences. Data rates are going to be increased with 1024 QAM, latency reductions. We're going to see greater IoT scale, which we talked about. We're going to see higher density, higher efficiency with technologies like OFDMA and BSS collaring. Again, we're going to go into these each one a little bit more detail. Now, some of the use cases, really 802.11ax is really going to be the future for wireless LANs, and some of the reasons why we'll get into. But if you look at the clients that are out there today, including smartphones, tablets, laptops, et cetera, they're starting to support 802.11ax, and really they're being offered in most, if not all, latest models today. Like I checked, if you go out to Apple, check the latest iPhone, all the iPhone 11 models support Wi-Fi 6. Anything prior to that obviously doesn't. I took a quick look on Dell. You pretty much can order any new laptop with Wi-Fi 6 adapter in it inclusive. So whatever devices you have, if you're going to be procuring new devices, most likely it may be the default Wi-Fi client may even be Wi-Fi 6. But something to look at and consider for future proofing as well if you're buying clients today. So some of the use cases for Wi-Fi 6 include, kind of mentioned some of the stuff, the 4K 8K video, and that's going to be supported to multiple simultaneous users, and that's not going to be just the enterprise. It's going to be great for consumers. So if you're like me and you got teenagers, and it's going to allow everybody in a household to stream videos and not have to yell at your teenagers to get off the Wi-Fi just so you can work. So some other use cases will include augmented reality, virtual reality applications, and ultra high density spaces like e-classrooms and stadiums. And there's definitely significant power savings for IoT devices. So the other use cases where customers are going to look to Wi-Fi 6 is like a lot of enterprise customers, when they're deploying new access points, they'll consider the latest greatest technology if they're retrofitting a building out a new space, or taking over a new space. They'll constantly look at that. What's the best technology to put in there. And also mission critical applications. So, they're increasingly requiring deterministic and predictability. So, Wi-Fi 6 is going to really offer that. Talked about IoT scale. That's another use case. That's, that IoT, the adoption really is continuing to outpace, the projections of IoT. So for all these reasons, there's a lot of reasons here that consideration of 802.11ax and Wi-Fi 6 is really warranted. So one of the goals of Wi-Fi 6 is really to provide high efficiency wireless, and this is accomplished by really two main areas. So, the first is provide high data rates more consistently in a typical Wi-Fi environment, and secondly, focusing on key performance indicators that will improve quality of experience. So we're going to dive in a little bit deeper, some of these specifics that really help meet the goal of high efficiency. So what's, there are really four areas that really determine airtime efficiency. So, first is the data rate modulation density, or, the technical term there is is quadrature amplitude modulation. So everybody's going to call this QAM. They're not going to say quadrature amplitude modulation. Secondly, the number of spatial streams and spatial reuse. And thirdly, channel bandwidth, which really dictates how many frequencies you can, can be modulated at a single moment. And lastly, protocol overhead. So again, we're going to dive into some of these a little bit more deeper going forward. We're not going to go super deep. We just don't have the time, but we're going to go semi. So I know this is an eye chart, but it really shows the iteration of modulation schemes, which is critical to understand over time for the generations of Wi-Fi. So if you look at the introduction of 1024 QAM, that was included with 802.11ax. This was achieved by pairing it with two different coding rates, and which creates the two modulation encoding schemes, the MCS10 and MCS11, which are the last two rows of this chart. So if you look at it closely, it really shows that the raw speed gain over 802.11ac, really you see that gain is about 25%, which really makes Wi-Fi 6 the first commercial wireless technology capable of true gigabit speeds with a single antenna. Even though even though the cell size, so from a coverage standpoint, the cell size of 1024 QAM is smaller, it allows for the higher density of users, and to increase and keep performance gains and really maintain a good quality of experience. So you're going to peaks of 1.2 gigabits per second with one radio, and there's the peak throughput for 4.8 gigabits per access point. It's really going to drive new capabilities and applications for, as we stated, for like enterprise grade virtual reality, augmented reality with some of these high-end wireless headsets that are coming out, for those types of applications. So in addition, there's support for 8x8 antennas. That's up from 4x4 antennas in 11AC. The additional antennas are going to allow for greater transmit beamforming and benefits, and also MRC gains. So all these improvements and benefits is really going to offset really some of the coverage deficits that you might see as compared to 11AC. But speaking of coverage, let's take a look at as a kind of a coverage example. So you can see this is a Ekahau heat map, and the coverage area in this typical enterprise office really shows the 1024 QAM, which is the area in the green and yellow. It's as expected, it is less than that of the 256 QAM coverage, which is the green, the yellow, and the gray areas. However, the areas underneath the access point, provide adequate coverage for, for 1024 QAM, and users will be able to achieve aggregated multi-gigabit speeds. Of course, gigabit speeds are per user and per AP are going to be dependent upon capabilities of the network and also of the end user device. So great example of that, like if you have a lot of older laptops or older mobile devices that may only support 802.11a, b, g, or n, those individual devices aren't going to be able to reach gigabit data rates. However, the aggregation of the access point may reach gigabit or multi-gigabit. So some of the considerations there, you're gonna be wanting to look at mgig support for the network side. So most APs, if not all the APs coming out for Wi-Fi 6 are going to have mgig uplinks to the network, and you're going to want to make certain that your networking access switches, so you're not limiting that that throughput supports mgig as well. So it's really, I'm going to spend some time because it's really critical to really gain an understanding of how and why high efficiency is built into Wi-Fi 6. So we're going to do a brief introduction to some of the technologies. Like I said, we're going to go semi-deep, and I don't have time to go, super deep on any of these. But we'll provide a white paper that goes a little bit deeper if you need to dive into any of these technologies further. So again, we briefly covered some Wi-Fi 6 performance enhancements, which included the new modulation scheme, 1024 QAM. We talked about 8x8 up to 8x8 spatial streams, which is up, doubling that from 11AC, which only support up to 4x4. Another area of airtime efficiency improvements is via term orthogonal frequency division multiple access. Now, I'm not going to say that anymore. I'm just going to call it OFDMA. And also the concept of resource units provides efficiency improvements. So with OFDMA, really what you want to take away from this, this technology provides, a benefit that all packets get processed faster. So let's really take a look at how that works. So first, we'll take a look at the previous, the OFDM, which is the predecessor in 802.11ac. That has a fixed overhead, which is independent of the payload size that that it can send on a transmission. So in second, it also uses full channel bandwidth per user. So if we look a little bit closer, each transmission opportunity is really limited to one frame. And if we look at an example of a truckload, that transmission frame can go up to 2,300 bytes. Now, if we look at our network, most typical networks have a typical average frame size of probably around 350 bytes. So if we throw the 350 bytes on there, you're going to see that there's going to be a lot of wasted space. And wasted space equals wasted airtime in wireless, and in other words, it's not really super efficient. And that's where Wi-Fi 6 is really addressing this with OFDMA. So it was OFDM, now it's OFDMA, and each transmission is really optimized and combined, using smaller resources, or sometimes you'll see the term subcarrier. So you're slicing that payload. These subcarriers are really user defined by the AP and can match application requirements, which really allows multiple clients to transmit in parallel, both uplink and downlink. So that's critical as well, getting more efficiency. So if we look at again our truck example, you can really see that IoT or real-time video streams, each getting a dedicated 2 megahertz channel with data rates that it can approach up to 14 megabits. Now that's a significant improvement. So you're not seeing that wasted space per transmission. So let's take a little bit closer look at OFDMA. If we look at this comparison chart, some of the important observations are, as more clients join a cell, higher density per AP, latency and jitter increases, which are really critical. If you get too many access points on older wireless, real-time protocols like voice and video could suffer. So in contrast, OFDMA, both latency and jitter are really, and even throughput, comparatively, are flat as compared. So this really allows much higher scale for real-time protocols. Let's take a little bit closer look at this. This is kind of a good chart where you see the lines in green on both the latency and the data throughput. Those not just the latency, but also the throughput is comparatively flat. So again, as client counts increase, both data throughput and latency kind of remains constant. Now with again, if we look at an example with 802.11ac, it's like, say if you had 25 clients per AP and it jumps up to 50, you're going to see a latency increase there. If you're on 802.11ac, if you're on older wireless technology, you're going to see an increase from 4x from an acceptable, say from an acceptable 50 megahertz, not megahertz, I'm sorry, milliseconds, from a 50 millisecond latency to an acceptable 200 millisecond latency. So, which we all know, if you're up to 200 milliseconds of latency for any type of real-time voice or video, that's going to be really unusable. Now, on the other hand, if you look at the OFDMA, delay is really, if you scale up to 25 clients per AP, you can see that you're still really around 50 milliseconds, which really results in a 2 to 3 times, scaling capacity with high quality. So it really just shows that Wi-Fi 6 is going to allow enterprises to design and implement voice, video, and data, on the same infrastructure and be able to scale, have superior quality and a lot better way to scale it. Let's also talk about we're going to briefly touch upon around what's called multi-user, multiple input, multiple output, or MU-MIMO. This was introduced in 802.11ac, but it was approved upon in Wi-Fi 6 or 11ax. Now, due to time, I'm not going to be able to cover, what is MU-MIMO and how it operates, but I'm going to rather discuss briefly some of the challenges and the benefits of this technology as it relates to 802.11ax. So, some of the questions people ask, like, well, what are some of the challenges of MU-MIMO? Really, the big challenge was the initial rate of adoption of clients, right? So, to really get the value of MU-MIMO, you had to have the clients rolled out because it was client dependent. So, having 802.11ac Wave 2 or 802.11ax clients really are required for MU-MIMO to function. Now, one of the things that's happening, improved and smarter clients are become really mainstream, and MU-MIMO is going to be more practical and easier to deploy most likely at a very accelerated rate in the next year or two. Let's take a little bit closer look at this. Some of the enhancements to MU-MIMO that was introduced in 11ax. MU-MIMO is now supported in both uplink and downlink versus just one direction. This is another factor that's going to improve latency for real-time applications like voice and video. Another enhancement for MU-MIMO is that transmissions per group has doubled to 8. So it used to be 4 in the first version underneath AC, and now it's up to 8. There are also other automated decisions and calculations at the latest version of MU-MIMO and 11ax that really increases the system performance. Now, these enhancements, along with an increasing rate of adoption of both 802.11ax APs and newer clients, is going to really help drive that, the value that MU-MIMO is going to provide, as a critical component to develop and have a high efficiency WLAN. Let's briefly look at BSS coloring. Now, this is another technical enhancement in 11ax, and BSS coloring and its ability for spatial frequency reuse is really great news for any customer that may be or has experienced co-channel interference. So I think most of us that have been in wireless for a significant amount of time, we've probably experienced issues when we try to create higher density wireless designs for both 2, 4, or 5 gigahertz. The limiting factor there, is the limited number of channels and the co-channel interference that it could create. Especially, it's challenging in the 2, 4 gigahertz band since there's only 3 non-overlapping channels. And 5 gigahertz has a lot more channels, but if you're doing channel bonding, depending on what type of data rate and throughput you want, if you're bonding a lot of the channels, you could run into similar limitations. So BSS coloring really allows access points really to distinguish which clients are associated to their registered access point. So you can see here there's 2 APs shown in the diagram. One's like pink, one's green, and really without that type of coloring and having this approach, typical clients will broadcast at full power and will really make the channel look busy, which really makes other clients kind of wait. So if it's busy, they have to wait, and even though they may be able to actually be transmitting at the time. So BSS coloring, that's where BSS coloring comes in. So that these smaller cells or BSSs can really identify the clients as being on the same team. So if you're on the pink team or the green team, that AP will then pretty much offer an incentive for the team members, like the clients, to reduce their power. So the AP will basically say to the clients that are in my on my team or my color, hey, you don't have to talk so loud. Please turn on your power. Hey, if you turn on your power, I'm going to give you preferential channel access. And really, as a result, the entire noise floor of the 802.11ax Wi-Fi 6 system goes down, and that really provides clients the best quality connection possible if that happens. So to summarize some of the benefits of OFDMA and BSS coloring, it's really reduction of jitter and latency. It benefits IoT clients and high density networks And channel reuse is now possible by leveraging BSS coloring. Really provides higher Wi-Fi performance. So I don't have a lot of slides around. I really only have one around IoT, but there's really two additional benefits I like to touch upon from an IoT perspective. So again, we talked a little bit about the concept of resource units, that we briefly discussed earlier. But this also allows you to control 2 megahertz channels, so that coexistence is much more effective. So that gives you the ability to support IoT devices a lot easier. The other technology is target wait time, and that's really going to allow, if you have a large IoT device rollout, that's going to allow you to set a time, depending on your application and in your requirements, you can set a time for those IoT devices to sleep. And the big benefit there is battery, conserving battery lifetime, which can be very significant cost and a great benefit for for an IoT deployment. So now we're going to roll into security. We're going to spend some time covering some of the enhancements here as well. So since WPA came out, that came out in 2004, it was really time for some significant enhancements, and thus they came out with WPA 3. And from a high level, some of the enhancements here are encryption of unauthenticated traffic, some improvements on password protection against brute force and dictionary attacks, and improved data reliability with 192-bit encryption. So we dive in a little bit deeper. Some of these further enhancements, really include, SAE, simultaneous authentication of equals, which really provides a secure peer-to-peer password-based key exchange. So, what does that provide? That really provides the replacement. So there might be a lot of organizations out there that are still using pre-shared keys. So you get the WPA PSK. This is going to replace that and be able to have a secure key exchange without having to do pre-shared keys. So that could be significant for a lot of organizations that don't want to manage pre-shared keys going forward. OWE, or opportunistic wireless encryption. There's a lot of good use cases there. For enterprise guest access and also for small office or home office users, it's going to be great technology. Each user receives individual per link encrypted messaging. And the other key thing is that it doesn't require any special configuration or user interaction, but it really provides a higher security than a common or shared or even a public, pre-shared key type of architecture. So the OWE is really going to provide an evolution for a lot of open, unencrypted type of use cases like hotspots. So you're going out to your Starbucks or other hotspots like that roll out WPA 3 and leverage OWE. That's going to protect against a lot of type of passive attacks, for hotspot locations. The Suite B cryptography, that's an NIST standard, and that's aligned with the commercial national security algorithm, the CNSA. Now the use cases there, they're really specific. They're around government, medical, financial networks that really have that have compliance requirements and specific regulations that they have to meet. Right now, Suite B is an optional feature for the certification. So the WFA, the Wi-Fi Alliance certification, WPA 3 is specifically the Suite B is an optional feature there. So the reason I bring that up and just mention that is if that's something, if you're in a government, medical, financial, and you want to start looking at Suite B as hey, I want the highest level of cryptography. You want to look at your AP on an AP basis to see if it supports it or not, because it is optional at this point. Lastly, the device provisioning protocol. It's really a feature for deploying these security settings easily to masses. So if you have a large scale of IoT devices, device provisioning protocol may be a feature that you might want to take advantage of and see a lot of value from. So WPA3 client support, you can see Intel, Microsoft, Qualcomm, Broadcom, they're all really, the leaders in the pack here, right? There's many other vendors, and, this is just a short list. There's going to be many, many more ramping up very quickly, as Wi-Fi 6 and the H11X gets a lot of traction. Now, for those that leverage Cisco, some specific Cisco support here. WPA3 is supported on 802.11ac, the Wave 2 APs, not on, unfortunately, not on Wave 1, and obviously supported on the 802.11ax and specific versions of software that you need to support here. So obviously it's supported both on the AeroS, again, it's back to the AeroNet days, and the latest, Cisco IOS XE that's being supported on the latest access points. So some more security enhancements. This is unique to Cisco. It's really the introduction of encrypted traffic analytics, or ETA, for the Catalyst 9800 wireless LAN controllers. Now, ETA has been around for a little bit. That was first released in the Catalyst 9000 series switches for wired networks, and is now available for wireless Cisco wireless customers. For those that may not know of or heard of yet, ETA yet, it's really a technology that allows organizations to detect malicious content in encrypted traffic, really without the need to decrypt it. So a lot of customers that may need to look at traffic that's encrypted with HTTPS, SSL, et cetera. They may be using or looking at decrypting it to be able to analyze it. And there's a whole slew of extra costs. It's typically pretty costly to unencrypt a lot of traffic, especially if it's high data rates. That could get pretty cost prohibitive quickly. So ETA really helps mitigate that, being able to look at and detect traffic, without having to decrypt it. Now, if there's anybody that wants more information on some of these technologies, just let us know. We'll be glad to dive deeper and set up a separate meeting if there's something that sparks anybody's interest. We're going to briefly touch upon wireless micro-segmentation. Again, this is a unique to Cisco systems product portfolio. I only have one slide here. There's probably a lot of organizations that still use VLANs and ACLs for segmenting traffic on both wired and wireless. It's typically manual effort, and sometimes it could be quite time consuming if there's any significant changes, and sometimes it could be error prone. And really that's where Cisco's SD Access really offers a completely automated micro-segmentation solution for wired and wireless client access, really, and eliminates that dependency on VLANs or subnets. And it defines group-based access policies per user, and that policy it follows the user identity no matter where they access the network. If the same user accesses on wired or wireless, they're going to get the same policy, and it's independent of subnet or VLAN. So Cisco, the SD Access is really comprised of DNA Center and ICE. ICE is Cisco's network access control solution, and it leverages a technology called security group tags, or SGT. That's what provides that group membership that allows for seamless micro-segmentation really across enterprise, no matter where the user connects to the network. We'll talk a little bit about enhanced analytics with Cisco DNA, and that's really offered through DNA, Cisco's DNA Center, and specifically around Cisco's DNA Assurance. Cisco's assurance, DNA assurance is really leverages artificial intelligence and machine learning, and that really allows manual troubleshooting to be reduced or eliminated, and it really greatly eases the time and effort spent investigating and tracking down service issues. So we're going to go through some what I call pseudo demos. It's not really a demo, but it's some screenshots that really illustrates a few use cases that may be common. use case number 1. I'll click here instead. So use case number 1, client is failing to onboard to a network. Typically, the dashboard, that where you can start out is pretty intuitive. And you can drill down into, some issues that, that this client's experiencing, and you can see, you can see what's red and the clients aren't onboarding, and you can actually see that there's some sort of happening with AAA. You can actually there's some nice tools where you can do correlation, so you can see if that's correlating to any type of events, maybe a poor RF coverage or something like that. You can easily correlate, with assurance. And the other feature that they do have is intelligent capture, where you can really go down into the packets. And here you can see that, looking at what packets are read, it actually tells you what type of packet it is. It's actually an authentication packet that's where it's failing at. So that helps you determine and quickly drill down. Okay, well, maybe it's something with my AAA server needs, maybe it was got stuck or needs to be rebooted or something like that. But you can see here that, looking at that packet analyzer, you can quickly tell, like, oh, do I have a DHCP issue or an association issue with the access point or authentication issue and things like that. So second use case, clients having poor wireless experience. So again, great dashboards, they're real time, you can drill down quickly and easily, then you can drill down into what the client is doing. And one of the nice things here, you can actually go back in time and actually take a look at it. So they have a time slider, so you can take a look exactly what time it happened and drill down into the major events. You can see that the reauthentication for this client was failing. And again, more capturing capabilities, so you can do some look at further access point and client statistics for ease of Wi-Fi troubleshooting. So the third case we got here real quick is client is having poor application experience. So, again, we can start with with a nice dashboard, and you can pick which applications you want to monitor. So you can look at different, the most critical business relevant apps, and you can, do some analytics and top 10s and things like that and drill down and see what's happening. Again, then you can look at each application separately. This one, as an example, was Skype for Business. Obviously, you can then take a quick look, say, hey, am I having any significant packet loss or latency, jitter that would, impact the business application. And if it's a critical business application, you might want to set up some, simulate, some packet simulation as well, and be able to make sure you're meeting some SLA. So if you have a set SLA for a business critical application, you can definitely do that and monitor that with assurance. So we're gonna dive into real quickly the Cisco product portfolio, see what the Wi-Fi 6 access points have, and we got the 915, the 917, and the 9130, and I think we're getting close to the end of the time here, but I think I only got a few more slides, and I'll probably skip over the overview here, just to let everybody go. But just to give you a quick overview, there are 3 certified access points. The 9117 was a precursor to Wi-Fi 6. And actually, Meraki has 3 Wi-Fi 6 access points as well. And again, Cisco has an end-to-end solution, as you can see from here, from the access points to, if you're going to look at the complete end-to-end intent-based networking that Cisco offers through SD Access, there's a complete roadmap for there. So I'm going to skip forward to the summary because I know we're out of time, but if anybody is on the call here that doesn't know of SMP, please let us know. We'll love to give you an introduction of who SMP is and our value. But to summarize, Wi-Fi 6 has full service provider carrier offload, convergence of IT and IoT, a lot of real-time application support with enterprise-grade 4K video, augmented virtual reality, carrier-grade voice support, and a lot of security enhancements that we've covered. So I apologize, went over a little bit 2 minutes, but I kind of wrapped it up real quickly there. We'll get out the presentation to everybody. If there's any questions, we'll definitely follow up with you directly. Thank you, and thank you very much for attending. Hey, Jennifer, did we want to open up the lines or not?
If you have time, John, I can certainly open the lines up for a couple of minutes. Or I know that we had an end time of 12:15. So if anybody does have questions, I will go ahead and open up the lines. Otherwise, if something comes to you later on, go ahead and feel free to email your rep or solutions@smp-corp.com.